I will be discussing how to solve systems of equations, both linear and nonlinear, but I'm going to use the substitution method. For example 1, we're giving the different types of systems. We have a quadratic and a linear together. So what I'm going to do is just isolate a variable. I have a choice. I can either isolate my x, or I can isolate my y, or I can just literally substitute in if I wanted to. So what I mean by isolating, I'm going to rewrite the second system as, instead of, I'm going to add y on both sides. So y is by itself and it's positive. So what that's going to look like over to the side is going to be y is equal to, and then I'm going to subtract that 15 on both sides. And then again, what that's going to look like, I already have a 3x over there. So 3x minus 15. So I just basically rewrote the system. So that's what I'm working with instead of working with what's shown over here. And what I'm going to do is I'm going to substitute it in for y. Because it says y equals, I can do that. So I'm going to take all of what I just wrote, or what I just simplified and isolated for y, and I'm going to substitute that in. So this is what it would look like. X squared is equal to -2, and I'm going to replace that y. And since it's an expression, I'm going to put it in parentheses as 3x minus 15. And if I go back up to my first system, it also says minus 23. So now I'm just going to go through and I'm going to simplify everything. I still have x squared by itself is equal to, now I have to distribute. That was the purpose of me doing parentheses. I have -6x plus 30 minus 23. I can combine these and simplify it even further, which would leave me with x squared is equal to -6x plus 7. So now what I want to do is put everything on one side and set it equal to 0. And I see that I have x squared. That tells me that I'm going to end up factoring or using a quadratic formula if I can't factor it. Let's see, I'm going to add 6x and subtract 7. What I do to one side, I do to the other. Add 6x and subtract 7. And notice I am not going to combine those two because one has an x squared and one is simply an x. So I have x squared plus 6x minus 7 is equal to 0. So for factoring purposes, what I want to do is I want to look at what times what will give me this x squared. Well, that's easy. That's simply x times x. Next, I want to look at c. If there was a number here, I would multiply those two together. So the number in front of x squared is understood to be 1. So 1 times -7. What are the factors that will give me -7, but they would add to equal +6? Well, 7 is a prime number, so I know that the factor is 7 and 1. Now I just have to figure out the signs. The bigger number between 7 and 1 always takes the sign of the middle term. So the bigger number is 7, and the sign of the middle term is plus, so that's the sign that's going to go with it. Now you have to ask yourself, 7 times what will give me -7, but also add to give me +6. This has to be a -1. So I've already factored. You can do that or the box method, which if we have another, in example 2, I will show you the box method possibly. Now what I want to do, since each one of these factors are set equal to 0, is ask myself, what can I put in the place of x to make it actually equal 0? So I can set each factor equal to 0 and solve for x, or I can recognize it's just going to be the opposite sign. X in this case will be -7. In this one, it will be +1. So if you substituted those x's in for those factors, you would in fact get 0. So now what I'm looking for is actual coordinates. So if I go back to either one of these systems up here and substitute in what I just said x will be, I can find my coordinates. So what I'm going to do is the part that I already highlighted here, I'm going to go ahead and use that to substitute in. So when x is 7, y is going to equal, so we're going to substitute -7 minus 15. and just keep going. 3 times -7 is -21, minus 15 or plus -15, however you want to read it. And that's going to simplify to y being -36. So in this case, the coordinates will be x is -7, which is what we initially substituted in, and therefore y is going to be -36. So if we were graphing, that's a coordinate that we would use. In the other case, y is going to equal 3 times, well, this time we're going to use x is 1, still subtracting it from 15 because we're still using this system. Y simplified is going to be 3 times 1, which is 3, minus 15. Y is -12. So when x is 1, y is -12. So these are my two answers for this particular system. For example 2, again, we have two choices. We can either isolate the x, well, we have more than two choices. We can isolate the x, we can isolate the y, or since y is already isolated here, what we can do is just take, go ahead and isolate this into y, and then that way we'll just take whatever the simplified part is and we'll substitute it in. You'll see what I mean in a minute. So what I'm trying to say is for this first system, y is already by itself. So I'm just going to add 4x on both sides. So that's going to give me, I don't want to keep that there, so hold on. I'm going to add 4x, which is going to give me the positive 4x. I already have a positive 32 over here. So now, in both of my systems, the y is isolated. So what does that mean? That means that I can actually take this y equals here and substitute it for that y because they are equal. They're the same thing. So I'm going to rewrite that as x cubed plus 8x squared, which again replaces my y because y equals that. Y also equals this. So I'm going to set it equal to 4x plus 32 because y will equal y. Now I just want to simplify it. What I notice is all of these x's have different degrees. So even if I moved over to the one side, I can't combine them. So what I'm going to do is I'm going to move everything over to the left-hand side, and then I am going to factor. In doing so, that will look like minus 4x minus 32. And if had I seen that before, I could have left that above like that. But it's okay. So minus 4x minus 32. And what's going to end up happening is on the right-hand side, that's going to zero out. And on the left-hand side, I'm going to end up with 4 terms. I have x cubed plus x squared, 8x squared minus 4x minus 32 is equal to 0. So I can look at this and I see that I can factor by grouping. So I'm going to show you that way as well as factoring by the area model or the box method, if that's how you want to look at it. What you're doing really is you're separating this. And on the left-hand side, I see that the greatest common factor is x squared. What's left over will be x plus 8. On the other side, I have to pay attention to this negative. Excuse me. When I factor that negative out, it's going to affect what's left over. So I can factor out a -4, and I'm left with x, but this time this sign will change. So it's actually going to be a positive 8. I know that I'm on the right track if everything in my parentheses looks exactly the same. What's left over, I'm going to put it in its own set of parentheses. So I have x squared minus 4 times the quantity of x plus 8, because that's now my greatest common factor. And I'm setting that equal to 0. I see that I have an x squared. That means I can further simplify. So that's what I'm going to do. This happens to be a difference of 2 squares. So again, I'm going to use that same method I used a few minutes ago. X times what will give me x squared, x times x. And then I need two factors that will give me -4 and then 0 out the middle. So the number will have to be the same. It's going to have to be 1 positive 2, 1 negative 2. So when I multiply it, it's -4, but when I add it, it is in fact 0, along with the x plus 8. Set that equal to 0. What can I put in the place of each of these x's to make it end up being 0? In a case like this, where your leading coefficient is just 1, all you have to do is just switch the sign. So x in this one is -2, x in the next one is +2, x in the next one, and the next one is -8. So that's factoring by grouping. For those people who do not know how to factor by grouping, let's go back to this part. What we want to do, since we have 4 terms and we have 4 boxes in the area model or the box method, is just go ahead and put in those terms. X squared cubed, 8x squared, -4x, and -32. Focus on the first row only. What is the greatest common factor between the two? What you can take out is x squared. Once you figure that out, you can figure out everything else. X squared times what will give me x cubed? Simply x. Now, x times what will give me -4x? -4. And then -4 times what will give me -32? Watch your signs, +8. That's one way. There's other ways to do it. So what did I just do? I took my x squared, multiplied it times x, put my answer in that first box. Took my x squared, multiplied it times 8, put my answer in the second box. Then I went to the second row, -4 times x, put my answer in the second row, first box. -4 times +8, put my answer in the last box. And you'll notice that these are now my new factors, which mirror what I already came up with when I was doing factoring by grouping. Once I get to this point, I notice over on this side that I still can factor further. That's when you use another box if you choose to use this method. For the first box, you would put the x squared. For the last box, you will put -4. You're looking for two factors in the middle that will get rid of the x value, but will multiply to give you -4, because again, you're multiplying 1 times -4 to give you -4. What two factors can I multiply to give me -4, but will 0 out if I add them together? Well, I know it's 2 and 2. And again, one is going to be negative, one is going to be positive. Does not matter which one I put where, it just has to have an x after it. And using the same method above, factor out the greatest common factor, which is going to be x. X times what is x squared? X times what is 2x? X times what is -2x? And there's your factors. So you have x plus 2, x minus 2, which is what we said over here. And you still have that x plus 8. You have to keep up with that as well. So you would still get the same answer using a different method. Now, our whole goal is to actually find coordinates. So what I'm going to do is go back to the y equals 4x plus 32, and I'm going to substitute each of these x's there to see what would happen. Let me go up some more. So substituting y equals 4x plus 32. Y is equal to, the first one is when x is -2. Then I have -8 plus 32. So therefore, y would equal, let me see here, 24. 32 minus 8 is 24. So my coordinates over here would look like -2 as my x and 24 as my y. Then going on to the next one, when x is equal to +2 plus 32. Keep simplifying. 4 times 2 is 8. 8 plus 32 is 40. So when x is 2, y is 40. And then lastly, let's just go over here. y is equal to 4 times negative 8 plus 32. And then y is going to equal 4 times negative 8, which is negative 32, plus 32. Y then becomes 0. So when x is negative 8, y is 0. So these are my 3 coordinates that I would be working with based off of my answers for those systems. And then my last example is going to be example 3, which deals with logs. So what I want to do for that first one is I am going to rewrite this in exponential form. So what that looks like is taking my base, going to the opposite side and coming back around to the first side and getting rid of the word log. So that would look like y raised to the second power is equal to x. So you notice I've isolated x by itself. So on the second one, I'm just going to leave it as is. And I am going to substitute this in for x because I said it equals x, right? So that's what I'm going to do. And that would look like log base y of 16 times. This x is now y squared. Just follow my arrow again. That is x. And that's going to be equal to 6. Now what I want to do is it's currently in condensed form. I want to expand it. So I'm going to expand it out as log base y of 16 plus 2 times log base y of y. And that's set equal to 6. Well, I can write log base y of 16. And then I recognize I have a base, my log base and my exponential base are the same. So I can get rid of that. And really the 2 is usually still there. I can bring that 2 down. So that's what I'm going to do. But there's a plus there. So plus 2 is equal to 6. I want to get log on the side by itself. So I'm going to subtract 2 on both sides. And I'm left with log base y of 16 is equal to 4. I now want to rewrite this as an exponent. So I'm going to follow the same rule that I did a few minutes ago. I'm going to go from my base across the equal sign and then back over. Whoa, what is going on? Sorry about that. And so what that looks like is y, and then I get rid of the log. Y raised to the 4th power is equal to 16. And now I want to get rid of the exponent 4. So the inverse of the exponent 4 is the 4th root. So I want to take the 4th root of both sides. And that will give me y is equal to the 4th root of 16. Well, what that means is what number times itself 4 times will give me 16. If you don't readily know that, what you do know is 4 times 4 equals 16, but you can further simplify. We're looking for 4, the same number 4 times. So 2 times 2 times 2 times 2 is the 4 numbers that I'm looking for. So if I can get 4, one group of 4 for a particular number, then I can bring that number outside of the radical. So in this case, y is simply 2. So now I'm going to go back and I have to check it. You always have to check your work. So when I check this, I am going to use the first system. Log base y of x is equal to 2. And I just said that y is 2. And let's see if this is true. I want to rewrite this as an exponent. So I get rid of the word log. And what that looks like is 2 raised to the 2nd power is equal to x. So therefore, if I simplify it, x should equal 4. So I take this and I test it again. So if well, that was me testing it, sorry. So my answer is going to be 4 and 2. So putting that here, let's just go to this one. Log base 2, and we said x is 4, and it should equal 2, and that is true. 2 to the 2nd power does in fact equal 4. So we know that we did this correctly. You can also check all of this in your calculator to make sure you're on the right track, but My final answer here would be this, because -2 would be an extraneous solution for the fourth root of 16. It wouldn't work. Extraneous solution. Okay, like, subscribe, and I hope you guys have an awesome day.